Let's do one more topic here to finish up this chapter. Let's look at the critical angle. So the critical angle is an angle that tells you if a ray is going to be able to escape out of a certain medium. So if you have a medium that has N1 and then you have a ray of light, and if N1 is higher than N2, then you want to know, well, is this ray of light that is incident on this boundary here, is this ray of light going to escape into this second medium? Is it going to go through? Is it going to refract? So that's what the critical angle will tell you. So the first thing that you want to be able to do is to calculate the critical angle. The equation for the critical angle here is derived from the fact that it's the angle at which the refracted ray is 90 degrees. Now you don't really have to worry too much about that, but that's where it comes from, that there's a certain angle of incidence at which your refracted angle is an exact 90 degrees. So that critical angle is determined by this equation. So you can take the inverse sign of that equation and to get the critical angle by itself equals inverse sign of N2 over N1. The good thing about this is that if you flip the indices, you'll get an error in your calculator. N1 must be greater than N2 for this equation to work. Okay, so now that you have found this critical angle, this special angle that depends only on the two indices of refraction, then you want to know, okay, now I have a ray in a random direction that is hitting my material, my boundary. Is this ray going to escape? And this is what the answer is here. If this random angle here is greater than the critical angle, then none of the ray is going to escape. So this special angle that we found here became the critical angle. But this is just a random angle that we want to know, okay, is this ray going to escape? So you compare this angle to the critical angle. If it's bigger, then all of the ray will be totally internally reflected and none of it will be refracted, none of it will go into that second medium. So that's the idea here. So the first thing that you should do whenever you are traveling from a high index to a low index is go ahead and calculate that critical angle so that you know what the diagram is going to look like. If theta I is greater than theta C, then it's going to look like this. If it's not, if theta I is smaller than theta C, so let's say that we have a very small angle of incidence here that happens to be smaller than this critical angle, then that means that the light will actually go through, and actually it's going to go through this way, right? Because it's going from a high index to a low index, so it's going to refract away from the normal. So you should be able to know that it's going to look like this. Now, technically, all rays, part of them are reflected and part of them are refracted. But if the question says, what is the angle of refraction, but the angle of incidence is greater than the critical angle, then you would say there is no angle of refraction because total internal reflection occurs. So that's why you have to check this first before you can go ahead and calculate that angle of refraction.